All right, we're gonna move right along. We have Jakob Krell, who's gonna talk to us about using Julia with the new hotness in typesetting. Is that what we would call it?
What was that?
We would call it Typstry, the new hotness in typesetting. All right, there you go.
Hello, everyone. This is Typstry. And so as a quick outline, I'm going to introduce what Typst actually is. And then we're going to get into the package itself with the command line interface from Julia, how to use the package for Typst formatting, and then more generally Typst in the Julia ecosystem and future directions we can take this package, and just in general use Typst. So this is a relatively new markup-based typesetting system. It's just over 2 years old, but in that time, it's gathered over 44,000 GitHub stars. That is to say that it has a strong start and promising future. I think everyone who uses it and then is involved can see that. So that feels really exciting. It also exports to PDF, PNG, and SVG. The latest release really has experimental support for HTML and like very rough edges. And so each release afterwards, they're going to be adding more and more support. So over time, that will be fully fleshed out. So why should you use Typst? It has fast incremental compilation, good error messages, intuitive syntax, and is open source, free to use. They do have some paid features because they have a team, they want to make money, but they're committed to keeping the language and code open source. It's not for everyone. It might be too new, like it doesn't have some packages or some features that you need. For example, HTML. Support just isn't there yet. And again, it's only 2 years old, so it hasn't had the time to build up and develop its ecosystem. You might be wanting to write a paper and submit it to a journal, and it just says, no, we don't accept that. We can't do that. And you might just like LaTeX, and that's okay. I am unfamiliar with other, I never got super into LaTeX, so you might have some other reasons why you personally don't want to use this. Here are some examples of what it looks like. So again, it's a markup-based typesetting system, and this is an example of the markup. So we have like the raw text, we have different modes like markup, code, and math, different lists. Here's an example of their code. So in this first line, we have a loop, and in each iteration of the loop, we're rendering some math. And then in the next one, we're creating a text box and coloring it with a color gradient. We can see that here. And I personally find this like easy to read and easy to understand and use. And it just looks nice. Here's another example of their math mode. This example is taken from their GitHub README. That's probably, like the image that this is part of is probably the best like elevator pitch, I'd say, for the language. So I'd encourage you to take a look at it. And again, it just feels readable, easy to use. I think we've had discussions in Julia about how like we want to write our code in as close to the formal languages as possible, and really close the gap between our code and the math and the domains that we're working in. And I think this helps out in that sense. So the origins for this package, I learned of this language, I thought it was cool, and I was like, well, what if we had LaTeX strings and LaTeXify, but for Typst? I think that would be pretty cool. And I saw a little bit of Typst in Julia at the time, but I thought it'd be fun to just try it out, see if we could get something going. And so here's what we did. This is a general structural diagram of the primary objects and functions you'd be interacting with in Typstry. So in the top right corner, this Typst.jl.typst, that is the Typst command line interface itself as a JLL package. So 2 years ago at the JuliaCon hackathon was when I actually first started coding this project and using that, just learning how to use that resource to compile a document, and then from then I've built the rest of the structure from there. So we're going to start on the right side, which is the command line interface, and then move to the left side, which is the Typst formatting, and progress from there. So this is the build tarballs file. So if Typst releases a new version and you want access to it, you go to this file, you update the version number, and you update the git hash, and if that builds correctly, then it will release a new version of Typst.jl. Myself and a couple other people have done that, but if we're ever slacking on it, feel free to. For example, if you're paying attention, you might notice we have not updated to 13.1 yet. So here's the command, which just wraps over this the command line interface, and it supports the general command interface. In the future, I'd like to add more methods for like abstract commands. The star here for implements means this is an unspecified Julia interface, so I'm just looking at the methods and doing my best to follow their implementation. And as an informal interface that's subject to change or possibly be implemented incorrectly, but it seems to work well so far. Also for these to-dos, you'll find several more of them throughout the talk, and if any of them stand out to you, feel free to tell me like, hey, I want that one, or just express your interest. You're welcome to talk to me about them. Yeah, I'd love to hear your thoughts. Yeah, so you can see when you run this help command, the output is from the the CLI itself. I've left out some of the output because it's too big for the slide. Then we also are able to construct that using a command macro. It works just fine. It's a bit primitive at the moment in that it doesn't have interpolation. The Julia's command interpolation rules are a bit different than the string interpolation rules, and I haven't learned what those are yet. So that is another to-do. We'd like to implement that, make it easier to use these command macros. And then I also ship the Julia Mono artifact so that you can render your documents using this typeface from Julia, and these are all the different ways you can do that. So the first one you see is the font path flag on the Typist command line interface, and you can also set the Typst font path environment variable to that. And if you don't, you can use the same for other fonts as well. So to go through the formatting side of the architecture, we're going to be implementing this example type for the formatting and see how that interacts with the functionality available there. So we have the struct JuliaCon. The purpose is just to define formatting for it. So we first implement Typst context, which is similar to IO context, where you're passing metadata to the formatter, and then show Typst, which is the formatter itself. You can see this you might think it could be easier to just do it through show itself rather than show Typst, but then you'd have to be unwrapping this metadata each time, and so I'm providing this to just unwrap it for you. You have the context available, and you have the IO, and you can go as normal. So you can see in this show Typst function, we're just printing hi JuliaCon, and then we're getting the year from the context. And this Typst context function that we're implementing provides a default value for that, that can be overridden in a couple of different ways, which we'll get to soon. So to start, now that we've implemented that, you can just call show typest on it, and it will format it as we've defined. The default context can be overridden with both the keyword parameters, such as this year equals 2026 on the second example, and also, or by providing a types context, such as in the third example. Those two are mutually exclusive, just to make it a bit easier to provide that data. And then we also have a type string, which essentially it takes any Julia value that we have implemented show typest for, and then formats it and holds it in the string. So we're using the show types method to print into the string here. And again, you can see that it uses the context in the same way as with show types, where you can provide a types context. You can also provide a keyword argument as well. In the second example, we see another type wrapping our Julia construct. So this types text acts similar to text does in Julia, where text says it renders its object with print. And so types text, the implementation for its show types method is simply print as well. So that is a way to just reuse that, I guess. Yeah, and once again, we're using a string macro to construct these strings. So this is kind of a feature similar to LaTeX strings. In the first example here, you can see we're using the $signs, and it's not interpolation. So this string macro is very similar to a raw string, but it also supports interpolation. And you can see in the second example, we're using the backslash and parentheses to indicate that we're interpolating. And then it's formatting that as if you're doing a call to Typst string. That's probably my favorite feature of this package. I know at least one person has disagreed with that, but I think it's just fun to use. The interpolation also supports escaping, as you can see in the third example. Render kind of brings the formatting and command line interface together as just a very convenient, easy way to take a value, format it into Typst code, and then render that Typst code. You can see in the first two examples, we're again using we're able to override the default context. In the third example, we have some options to specify what files are generated, whether it opens in like a default viewer if your machine has one available, and if it applies the ignore status flag to the command so that if it errors, it doesn't have a Julia runtime error. A little more info on the types context. So this is an abstract dictionary that implements that interface and iteration as well. And this numbered list here, this is the precedence for which context values take priority. So to start with, we have the types context or keyword parameters, which, like I said before, those are mutually exclusive. And if those are specified by the user or by a show types method itself, then we want that to take the highest priority. Secondly, we have a types context given in an IO context. That's also high priority because that can be specified by a user. But that first one exists so that even when you have this context in an IO, the show types methods are able to override that. Our third priority is the method we implemented at the start, which is the default context per type. And then finally, there's a default global context. So if you're implementing this for your own type, you can specify those defaults per type, and then Typstry has this global context variable as a fallback, and you're able to modify that to your liking as well. This is the default context, and they're used in several of the show Typst methods that I've been implementing for base, or like just types from base. So mode, let's see. I'm not sure we went over mode, I don't remember. No, I think we'll have a slide for it later. Yeah, we had the different modes in types. You have markup, code, and math, and the markup's the default. If you want to enter into code mode, then use the number sign, and if you want to enter into math mode, you enclose that in $signs. And so this can indicate to formatting like, hey, we're going to render something in math mode, but the current context is that we're in markup, so it'll put those $signs for you. But if you know, oh, actually we're already in math mode, then you can say it's math mode, and it won't do that. This preamble is used in a couple of areas. So there's some show functions that use it, and also render will put that at the start of every document that you compile to it. And again, you can just change this however you want. So if you don't like my preamble, you can set your own. This IO is used in show Typst to format the values. So if you need, it just lets you set additional default data there. But again, if you're passing the IO directly, then this isn't used. It's only if that's not present in your call. Yeah, this is a function. This method just lets you format a lot of values in PDF, PNG, SVG, and Typst. I still need to add in the experimental HTML target. We might not, because that could also break notebooks if they prioritize that, and HTML isn't ready yet, so I might wait on that, but I should at least check it out. And I also need to test to see if these methods work in Quarto. But I do know that if you have something, if you define these methods and enter a value where show types is defined for it in Pluto or iJulia, then it will render it as per one of these formatting options. So these are optional, but I would recommend them if you are using this interface, because it allows anyone across the other packages to hook into this method without needing to know anything about Typstry. And you don't even have to use my package if you just want to use these anyways. Like, just do it. The more types we have in the ecosystem, I think the better. So we have some packages with interoperability for types. This is actually a recent one. So we have a Luxor weak dependency that Chromolian implemented, and I think that's pretty straightforward. We also have Typst Jellyfish, which if you were here last year, you might have seen. If Typstry is the Julia-to-Typst interface, then Typst Jellyfish is the Typst-to-Julia interface, wherein you can run and render output from Julia within your Typst documents. So as you can see in this, in the final JL call, that is Julia code. And so the final output from that block will be rendered into your Typst document. And this doesn't know anything about Typstry. It just uses the show interface, which is an example of why you should implement this. So any rules that he set there in his package, or any methods that you define that allow types formatting, will allow you to render your objects within a Typst document itself. This is the Julia side that you run in parallel to this Typst code, which provides the actual formatted results. We also have Makitech. I need to update the version, but it allows you to use Typst in some of your figures and labels and titles, things like that. I think it's a bit more limited at the moment, but it would be interesting to see if we can get some better Maki integration in the future. These are other packages that know nothing about Typstry, but they use Typst itself, and I recommend you check them out. This is something that I think would be interesting to do in the future that we don't have yet. So in LaTeXify, it has syntactic rendering, where you can give it an expression, and it will read that expression and render it accordingly in LaTeX. But that doesn't know anything about what that expression means. So you can see in this first example, you have y over x, and it just renders 1 over x. We're interpolating y in this particular case. And that is that is very achievable with Typstry right now. It's not currently implemented, but I would just need to implement show Typst for Exper, which I hope to do Saturday. And something that would probably take quite a bit more time is semantic rendering, and this could be probably called like partial Julia-to-Typst transpilation, because if we're lowering to this Typst function and providing it with the parameters, if we implement the show Typst method that corresponds to that, then we have semantic information as well. So we know that in Julia, using the star or multiply operator on 2 characters combines them into a string. And in Typst, we can do the same thing, just with plus and strings instead. So I plan to set up Typst function just to exist. In terms of actually implementing the semantic rendering, probably wait until Typst releases a 1.0 and is stable, because that's a lot of work. Something else that would be cool is to do Typst Unicode completion in the REPL. This is a very hacky way to do it. You can do it. I'm not going to ship this. There's a proper way to do it. I need to figure out what that proper way is and then actually do it. But I think that would be fun. Types use different names for these symbols than both LaTeX and Julia. And yeah, it would just be cool to be able to use those instead. Another possibility is to use auto instead of these specific modes. So in this second example, I'd send the whole string to the Typst compiler, ask it what mode it's in, and then it would infer that for me, so I don't have to specify the mode is in math. And then probably the thing I'm most excited for, this was in a Julia discourse thread. As soon as they officially release the HTML target, I will be dead set on making it possible to do Julia package docs mostly in Typst, so you can be sure I'll be working on it if nobody beats me to it. So expanding man, I really looking forward to that. We just got to wait for HTML to be finished up. And that's, final thing, these slides were written in Typst. Any questions?
Do you have any questions for Jakob? Yes.
Hi, thanks, fantastic talk. This is really exciting. I use Typst a lot. For some use cases where you need individual glyphs rendered from Typst, do you know if that's something we need to have like a wrapper around some internal Rust APIs to be able to get, or that's already available from command line somehow?
Are you talking about like entering the glyphs themselves, or like the name of them, like such as with this?
The glyphs themselves. So for example, in Makia, right? Like we have the way to render like a whole document kind of thing and then put it somewhere. But imagine you want to use the rendered glyph as a scatter symbol or something. Makia needs the glyph baseline, heights, whatever, so that they can dodge each other, for example. So you need individual glyphs things. So Makia can do the kind of layout. Do you know that information is available somewhere?
Let's chat after.
Okay, cool.
Anybody else? So calling expanding man's bluff is what you guys meant to like be that documenter you write in Markdown and then it targets types instead of HTML, or you write in Typst as part of?
I think the goal is that your doc strings and your doc strings can be types themselves, and instead of writing Markdown files, you're just writing types files, and that should integrate with Documenter.
Perfect. All right.
But I'm not expanding man, but that's what
I know you're not. But
yeah, that's what I would like to see.
Whoever they may be. Okay. All right. Good. If there's nothing else, let's thank Jakob one more time.
Thank you.